Good morning, everyone. So we are gonna do review today. Everything is gonna be just review. No new topics that I'm gonna cover today. All I will do is take your questions and answer them. So please get your questions ready and I'll answer all of your questions, anything and everything that relates to the homework and the midterm and not the midterm, the final exam and the review problems. So please give me your questions.
Could we go over 36 and number 37 on the midterm review? I mean, well, not the midterm review, the final review.
Yeah, I understand what you're saying. I make the same mistake. I keep saying midterm, final exam. 36 and 37?
Yeah.
Okay, so let's see what is 36 and 37. Oh, okay. So for this problem, what you need to do is this. Find the regression line. I explained it in one of the previous videos, okay? So your best and easiest way, first of all, Jerry, do you have a TI calculator or you're using
Yeah, I have a TI calculator. It's the line regression t-test, right?
Yeah, linear regression t-test, yes.
So that one would be...
So make sure that your independent variable is X and dependent variable is Y. That's something you have to make sure. Otherwise, you're going to get it wrong. So the first value is X and the second value is Y. So in one column, you want to put, let's say column L1, you want to put all the X values 20, 10, and all the way down to 30. And let's say L2, you want to put 3, 0, and all the way down to 2, okay? So that's how you want to put it. Then once you put it, go to Linearity Test and you will get two values, A and B, okay? And the equation, I think Y is equal to AX plus B, I believe. So check it. Yeah, I think it is AX plus B. So this is your, you kind of can think of it as slope and this is your intercept, all right? So that's what you should be getting. So that's what goes in here and round it to 100th place, okay? These two numbers, A and B. Once you get that, you need to predict the tip amount based on this regression model. What should be the tip amount if somebody were to spend $50? So you just plug in 50 for X, okay? You plug in 50 for X and then whatever value you get, that should be your answer to this. Now, how about predict tip for $210? Now, this is where people make mistake.
That would be, it wouldn't exist, right? Because it's outside of our range of data.
Exactly, you got it. Because look at the X values. I think the lowest value is 10, right? And the highest value is 200. So you can predict only X values that fall within this range, 10 to 200, okay? 10 to 200. And then what you do is say, basically, you can't predict it. If it falls anything over 200, which it obviously does here, you cannot predict. Or if you want to predict for $9, you cannot do it either. Is it okay, Jerry?
Right.
Okay, good.
Yeah. It was also number 37, I believe.
Yes, the next one, that's where I'm going. It's the same thing, exact duplicate copy.
Okay.
So here your X is going to be the number of hours that someone studies and Y is the score. So you plug it into the, let's say, L1 column and L2 column. So it's going to be 5, 3, all the way to 13.
So it would be the exact same steps.
Exact same stuff.
Okay.
72, 50, all the way to 95. Now, you do the linearity test, it's going to give you values for A and B. So you'll have an equation, predicted value y is equal to AX plus B. Okay, then for someone who studies 7 hours, you plug in X is equal to 7. Someone who studies 20 hours, we can see nobody studied 20 hours in this list, right? Smallest value of X is 3 hours, and the highest value is 15, so far 15 hours. So you can predict any hour between 3 and 15. However, 20 does fall outside of this range, so you can't. All right. Now, people, those who do not have TI calculator, you will need to go online and search for linear regression calculator. Linear regression calculator. Okay, that's what you want to search for. Once you search for it, you should get a few a few sites where you can go ahead and plug in the X values. They're going to ask you independent variable, which is X. Okay, the first numbers, and then they're going to ask you for dependent variable, which is Y values. So you plug it in, plug in the X values, plug in the Y values, and it's going to give you regression. So now one is the coefficient, the other one is the intercept. Okay, so make sure that you get the right value in the right place. So don't switch it. That's what I meant to say. So don't assume that this is B or the y-intercept, or this is A, the slope. So they may give it to you as M and B. Okay, so it's kind of like y is equal to mx plus b. So M is going to be the coefficient and B is going to be the y-intercept of the regression. Okay. Any question, anybody, about this problem, these two problems? By the way, I will be asking you at least one question on regression, and make sure that you don't make this mistake. Once again, I'm telling you, always check the bound for the X values, okay? Don't just blindly put it in, okay? Don't blindly put it into the equation. Yes.
I was doing number 36 and I plugged everything into my calculator, but I'm not sure if I did it wrong because I ended up coming up with a value for, well, the calculator came up with a value for A and B, and it's not accepting those as the right answer.
Okay, what do you have for A?
I have negative 0.6336.
No, you made a mistake. Did you plug in the, so what column did you put the, I think if I recall correctly, it's like 0.21 or something. Let me see. I have my calculator.
I have B as 0.21202.
Okay, so let me see if I still have the data. Okay, which one are we talking about? Number 36. 2010, is it 2010? Okay. Okay, L4 and L5, stat, calc. Lindreg, I get L4, L5, second, 4, second, 5. Yeah, it should be of the form, the equation. So I didn't use linearity test. I just used linear regression, okay? But linearity test should give you the same thing probably. Okay, I used linear regression. I got they have written it as y is equal to a plus bx. That's how they wrote it in the calculator. And I got a is equal to 0.445, okay? So, and b is equal to 0.206. So try this. A y hat is equal to 0.20x plus 0.44. See if it works.
No, it didn't work.
Didn't work?
Mm-mm.
Okay, round it to, so try this, round it to 4, 5. Maybe it is asking you to.
No, it still didn't work.
Huh? Oh, okay. Man. All right, my bad. So I probably asked you to round it to 100th place. So round this one to 0.21x plus 0.45.
Yeah, I did it. It didn't.
It didn't still?
Mm-mm.
Really? Okay, I'll check it. Okay, after class I'll check it. It should work. Are you logged out? So if you have been on the screen for a while and you're trying to go back suddenly, then you may be logged out and you don't realize that you are logged out. So what I would recommend, just
No, I
log
just
out.
logged in.
You just logged in?
Yeah.
Let me check it on my screen. See. Oops. Let me check it on my screen. Y is equal to 0.44. Y is equal to 0.44 x plus 0.20. Okay, this y is equal to 0.20. I just made a mistake. 0.20 plus 0.44. Huh, interesting. Let's see. Why should it not take it? 2, 1. I don't know what has happened. I'll check it, okay? Let me see if I can quickly check it right now. Give me 1 second, okay?
My values are different. And I just rechecked. I put in my line 1, it's going to be the x. In line 2, I put the y. I went to my stat test, linear regression t-test. X list is L1 and Y list L2. Then I calculated it. Then my A is still negative 0.6336 and my B is 0.2120.
Okay.
Which is different from your values. So I don't know where it's differing.
Okay, hold on. Let me see. Normally I use the Linearity Test. Okay, let me. They should yield the same value though. Okay. I'll check it. Let me check the problem first, then I'll go and look at other things. Oh. Okay. Okay, I had to search the problem, so I'm not sure where it is right now. So let me, I'll go ahead and send you an email, okay? All of you about this update. Is it okay? But the process should be the same. I'll have to check where the answer is wrong. But the process that I talked about should be same, and it should have worked. I don't see it right now here, but let me double check one more thing quickly, see if I can find the problem. Here I am. Okay, spring. This is testing for an exam review. Okay. Number 36 and 37, right? Okay. I have a slightly different number here. You're right. Okay. Let me see. Stat calc. Stat calc. Linear regression. Okay. Second 4, second 5. Huh. For some strange reason, I get the same answer regardless. So I have to check it. You're getting different answer, right?
Yeah, I'm getting let me check.
I tried both ways, Linearity t-test and linear regression. I get the exact same answer. So I'll have to check it, okay? I'll check it and then update you on this. So there is something interesting here. So I'll check the problem and update you. All right. Okay, let's go ahead. Keep moving. Next problem, please. I don't want to spend too much of online time, which I already did, trying to find out what's wrong. Okay, next, please.
Can we go over 34 and 35?
In the same group?
Yes.
34 and 35. Okay. Different spend localized trend by varied pair given data. So correlation. So for this one, what you need to do, you need to find the linear correlation between this. And how do you find it? Again, if you do a Linearity t-test, so you plug in the values. This one, it doesn't matter which way you put it. Okay, linear correlation XY. So you put XY values. Let's say you put it in L1 and L2. Put in the values 20, 10. Okay, and all these values. All right. So for this one, you'll find, so put in these values and you do the linearity test, is going to give you value for R squared and value for R. R is 0.96. That's what I got. Okay. R is 0.96. So your null hypothesis, so this is the linear correlation coefficient. We have spent a whole lecture, actually maybe 2 different days we talked about it. You find the Pearson linear correlation R, which is 0.96 here, then you use that value to do hypothesis testing, right? So your null hypothesis is always 0. That means rho is equal to 0. That means there is no linear correlation. This is not P, rho. Okay, and how do you put rho? Backslash RH. I think it should give you that. Then the alternative hypothesis is going to be rho is not equal to 0. Okay. So this tells you that there is no linear correlation. This tells you that there is linear correlation. Okay. Your test statistic is going to be this value, 0.96. 0.96. Okay. Okay. Hold on, I'm trying to type it in. Okay. What happened this morning? I'm getting everything wrong. Okay. So I'll have to check this value again. So test statistic
0.95.
Oh, is it 5?
Yeah.
Okay. I was trying to remember it from my memory. Okay, let's make it 0.95. All right. Okay. So this is 95. I thought my memory was good. I remembered it from the like few weeks ago when I did it in the class. Okay, so 0.95, that's your test statistic. And what are your critical regions? Okay, so for that one, you have to look at table A6. Okay, table A6, Pearson linear correlation coefficient. Okay, so that's where you're gonna find the values for critical region. Once you find that value, you kind of plug it in here, and then at the end, based on your test statistic, would you reject the null hypothesis? You will find something like, I don't remember, again, I don't want to assume anything, 0.707. That's the value for critical region. Okay. So obviously our 0.95 is greater than this value. Therefore, we will reject the null hypothesis that there is no linear correlation. Okay.
How do you exactly get those critical regions? Because I'm having issue with that as well.
You're having issue with the critical region as well. Okay.
Yeah.
Hold on. I'm gonna give me a second. Let me just pause the video a little bit, and then I will search. Okay. Okay. So you go to Pearson linear correlation coefficient table, which is the handout that I gave you. It's in table A6, okay? Table A6, which is this one. Then you have 12 pairs. So you subtract 2 from this, okay? So that's gonna give you 10. That's your degrees of freedom. So you look at row 10. So you look at row 10, and we are doing significance level 0.05, okay? So look at 0.05. If you look at row 10, you see a value of 0.632, and that should be your value. So go to table A6, look at the column that says alpha is equal to 0.05, and on the first column where it says n, okay, you look for 10. Okay, if you go to row labeled 10 and column labeled 0.05, you should get 0.632. You can put that as your answer. Does it answer your question, Jerry?
Yeah, that answers my.
Okay. Who asked for this question? Jonathan, did you ask for this question?
Yes.
Are you okay with it, or would you want me to?
The critical region one, I had a little confusion that.
Okay, are you okay now?
Yeah, the rest, yes.
Okay, all right, let me go ahead and do the problem again, just to make sure that you guys are okay. First, we are trying to do hypothesis testing based on linear correlation coefficient, okay? So if you have two variables, there is either a linear correlation or there is not a linear correlation, okay? There is either a linear correlation or there is no linear correlation, okay? Now, we write it as rho is equal to 0, meaning that there is no linear correlation. So how do you write rho? This is how you write rho, okay? \RHO, it'll give you rho. Rho is equal to 0. That means that's your null hypothesis. Your alternative hypothesis is gonna be rho is not equal to 0, okay? That means there is no linear correlation, there is linear correlation, all right? Now, once you find that, once you write these two, you have to find your test statistic. Test statistic is nothing but the linear correlation coefficient that you calculate, which is, by the way, R is equal to 0.95 or 94 point something, 0.95. So that's going to be your answer to this one. Now here, how do you write not equal to? By the way, you can type in \NE, not equal to. All right. Now, in the next step, what we're going to do, find the critical region. You have two sets of, 12 pairs of data points. So your degrees of freedom is going to be 12 minus 2, which is 10. Now, you go to table A6, which is on the very second page, by the way, in the handout. No, sorry, third, not even second, third page, sorry. On the third page, on the right-hand side, okay? Third page on the right-hand side, you will see something like this. N alpha is equal to 0.05 and alpha is equal to 0.01. We are doing hypothesis testing at 0.05 significance level. And this says N is equal to 4, 5, 6, 7, 8, 9, 10, and keeps going. We are looking at row 10 and column this one. And at this point, we are going to find a value. That value is 0.632. And that's how you find the critical region. Okay, so this is going to be 0.632. Now, you compare your test statistic, which is 0.95 with 0.632. All right, 0.632. So 0.95 obviously is greater than 0.632, right? So you'll reject the null hypothesis that rho is equal to 0. That means there is no linear correlation. At 0.05 significance level, there is linear correlation between the two variables. Jonathan, is it okay now?
Yes, thank you.
Okay, perfect. Great, let's move on to the next problem, guys.
Oh, can we do also 35?
Sure, 35. It's the exact duplicate problem, 35. Exact duplicate. So I'll tell you, again, what is it gonna be? Your answer to the first one is gonna be rho is equal to 0 and the rho is not equal to 0. This is not P, this is rho. And you test statistic. Does anybody have the test statistic? I don't want to use my memory, which failed me today. What is the linear correlation coefficient for this data set? Anybody has it?
0.86.
0.86. So this should be 0.86. Perfect. Thank you. And then your test statistic, then your, what is it? Next one, which is the critical region, which is basically the value that you're going to get from the table. Now, in this case, what you're going to get, look, how many pairs do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the degrees of freedom is going to be 10 minus 2, which is 8. Now we are going to go and look at the table A6. Alpha is equal to 0.01, right? So it has 4, 5, 6, 7, 8, 9, 10, and keeps going. In our case, we are interested in 8. So we are going to go 8 and this column, because we are doing significance level 0.05. And at this point, junction, we have 0.707. So you're going to put 0.707 here, okay? Then your R is 0.86, which is greater than 0.707. Therefore, you reject the null hypothesis that there is no linear correlation, okay? Exact same thing, exact duplicate. Any other question, anybody? Anything that I could answer for you guys?
I was having trouble for the critical regions on number 8.
Number 8?
Yes.
Which section? This one? Okay. All right. So let's go ahead and do the problem. Mark Zuckerberg and 50 minutes per, okay. Assume that the social network is normally distributed with population standard deviation 20. So you know sigma, claim at different from 50. Okay, so I'm assuming that you have read the problem. So your you're testing whether average amount of time people spent on social media is different than 50, right? So it's coming up. So what is your sample size? How many people you surveyed? You surveyed 200 people. So this should be a 200, right? N is equal to 200. So that should be your answer for this. What is your value for sigma? Sigma is the population standard deviation. Sigma, they give you the normal distributed population standard deviation. Sigma is 20. Okay. What is the null hypothesis? You're testing. So test a claim at 0.10 significance level that population mean is different from 50. So it's mu is equal to 50. That is your null hypothesis. And your alternative hypothesis is mu is not equal to 50. Okay, so that's null, and the next one is alternative. Okay. Now you test statistics. What is the formula for test statistic? I have to kind of look it up myself. Oh, where are you? Test statistic, what population sigma norm? So your Z star test statistic is X bar minus mu divided by sigma over square root of the sample size. So you can just plug in the values. So what does the problem say? It tells you, see, you surveyed 200 people that yielded an average of 40 minutes, okay? So X bar is 40 minus mu is 50 divided by sigma, which is 20, divided by the square root of the sample size, which is 200 right here. N is equal to 200. Then you simplify it, that's gonna give you a test statistic. Now, your critical region, that's the question you had, Alicia, right?
It was Maribel. And yeah, that was my question.
Okay, Maribel, that's the question. So we are doing our significance level alpha is 0.10, okay? But we are doing two-tailed test because it's either equal to or not equal to. So this is gonna be my right tail, and this is gonna be my left tail. So we have to divide alpha into 2. So it's gonna be 0.1 divided by 2 is 0.05. So this area is 0.05. This area is 0.05. And these are standard values. This is gonna be negative 1.645. And this is gonna be positive 1.645. So your critical regions are gonna be from negative infinity to negative 1.645 union 1.645 to positive infinity. So this is what you will put in this box. In this box. And just to show you how you put it, that's where you may run into problem. Put open parentheses, then minus sign, then put backslash INFTY space, okay? Then put a comma. Then put negative 1.645 close parentheses. Then for this union, put backslash CUP, cup. It kind of looks like a cup, space. Then 1.645, comma, backslash INFTY, infinity, space, then close parentheses. And that's how you should put the answer.
Thank you.
Then based on your test statistic and critical region, you will either reject the null hypothesis or you will not reject the null hypothesis. Is it clear, Maribel, everything?
Yes.
Perfect, thank you. Next question.
Can we do number 9?
Sure. Okay, number 9. For this one, you'd like to test a claim that ordinary act makes 15,000 a year. Blah, 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 poverty level, okay? So first of all, you need to find the average of these numbers, okay, which I'll expect you to find. So also make assumption that the distribution of income for the field workers is bell-shaped or normal. So that's an assumption we need. At 0.05 significance level, test the claim that the average income for field workers is different than 15,000 per year. So let's go ahead. What is the degrees of freedom, which is n minus 1? N is the sample size. How many data points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this is going to be 10 minus 1, 9. Simple. What is the value of the sample standard deviation? So I have showed it to you. I have shown it in the class how to find the mean and the standard deviation. In case if you forgot, you can do it in a couple of ways. You can either use the TI calculator or go online, okay, and search for standard deviation calculator. If you plug in these values, it's going to give you X bar and S, two numbers. And those are going to be your numbers that you will need, okay? And once you have those, S is the value that goes here. What is your null hypothesis? You're testing whether it's different than 15,000. So your null hypothesis, or H naught, is going to be mu is equal to 15,000. Your alternative hypothesis is going to be mu is not equal to 15,000. Now your test statistic is going to be T star next. All right, is going to be X bar minus mu divided by S over square root of the sample size. Now, X bar is something you will find, okay? Just X bar is just mean of the sample, right? Is the mean of the sample. So you just add up all these numbers and divide by 10. That's your X bar. To find the standard deviation, however, you can do it by hand, but of course I don't recommend. What you need to do, you just go online and search for standard deviation calculator and plug in these numbers. It will give you the standard deviation. Does anybody have the X bar and the S for this data set? Anyone has it handy?
For S, I got 3657.32.
3657.32. Okay, anybody else got this value? 3657.32. And what is X bar? Anyone got the X bar? Okay. All right, I trust you with that. So you plug in the X bar, minus mu is gonna be 15,000, okay? And divided by the standard deviation S, whatever it is, divided by square root of the sample size, which is 10. And then you do the calculation, that should give you T star. Now, your critical region is gonna be kind of like, remember, T distribution is a little bit stretched normal distribution. Your degrees of freedom is 9, okay? So, and we are doing two-tail test. So significance level 0.05. So alpha is equal to 0.05. We have to divide it into two tails, right? So alpha over 2 is going to be 0.025, okay? So area in one tail, 0.025. Area in two tails is 0.05. And if I look at the T distribution table, I'm looking at it right now. Okay. With the degrees of freedom 9, area in one tail 0.05, and area in two tail 0.0. Area in one tail 0.025, area in two tails is 0.05, and degrees of freedom 9, that's going to give you 2.262, negative 2.262. All right, so your critical regions are going to be from negative infinity to negative 2.262 union 2.262 to positive infinity. All right, that's what it is. So that's the critical region. Now you get T star from this calculation. Once you find the T star, you check whether that T star value either falls here or here. Okay, if it falls in either of this region, either this or this, you'll reject the null hypothesis that people make 15,000 per year, the field workers. On the other hand, you will not reject the null hypothesis. That's what the conclusion is. Is it okay? Whoever asked for it?
Yes, thank you.
Just make sure that you do not make mistake in finding the standard deviation and X bar. Other than that, it is very straightforward and standard process. And 3657, somebody found standard deviation. That sounds about right, I think. But just double check. So these are the only two things that you have to find, X bar and S. And just use the TI calculator or use online. As a matter of fact, I prefer that you use the online system because we don't want to be depending on any specific device. We want to make sure that we have access. Everybody has access to things freely. You know, calculating standard deviation and mean. There are many online tools where you can do it for free. So use those. Okay, and then there was a request for another problem. Let's see. Number 10. Hypothesis testing. Okay, you take a random sample of 15 students at your school and find that on the average they study 17 hours per week with a sample standard deviation 2.5. Based on this test, test the claim that, there should be comma here. Based on this, test the claim that the population variance sigma square is greater than 4 at 0.05 significance level. So your degrees of freedom is going to be n minus 1. So you took a random sample of 15 students. So n minus 1 is 14. So that's your answer. What is the value of sigma? So your null hypothesis is going to be, remember, sigma square is equal to 4, technically less than equal to 4. And your alternative hypothesis is sigma square is greater than 4. So sigma square could be equal to 4, right? So sigma square is equal to 4 or sigma is equal to 2. So this should be 2. Null hypothesis, alternative hypothesis, okay? This one, for the null hypothesis, I don't remember what I asked you to do. So you could try sigma square is equal to 4 or sigma square is less than equal to 4. I think this will work. And alternative is sigma square is greater than 4. Next, your alternative hypothesis of the test statistic. So what is the test statistic? So test statistic is going to be chi-square star. And the formula for that is very simple. N minus 1 times S square over sigma square. S, the problem gave you, I think, S is you found 2.5. So S is 2.5. So chi-square star is equal to N is, what was N 15 minus 1 times 2.5 whole square divided by sigma square 4. And you simplify this number and whatever you get, that's what it's going to be for chi-square star. Now, for critical region, so let's look at the critical region. Okay, so chi-square distribution, you should know that it looks like this, like that, stretched a bit, and it doesn't go to the left of 0. Now we are doing greater than, meaning one tail test. And what was the significance level? Let me see, is it 0.05? 0.05, okay? So we are gonna look at this area. Remember, chi-square distribution is cumulative from the right, not from the left. So this is 0.05. Now you have to look at the chi-square distribution table. Okay, so I'm looking at the chi-square distribution table with degrees of freedom 14, right? So, and area to the right point, area to the right of the critical value. So this is my critical value. Area to the right of critical value is 0.05 and degrees of freedom is 9. And if I look at it on the table, I get 16.919. So this is gonna be 16.919. So your critical region is gonna be from 16.919 all the way up to positive infinity. That's your critical region. So everything from here all the way to positive infinity. Now you have done the calculation here. Whatever value you get, okay? Whatever value you get here, that value, if it falls within this region, that means if it is 16.19919 greater than or equal to that value, then you will reject the null hypothesis. Otherwise, you will not reject the null hypothesis. And that's what your conclusion is. Let's say you get for this value 17. Yes.
The critical region isn't working in the problem.
Why?
I don't know. I typed it in. It's just not working.
15 students. So let me check if I got it right. 14, right? 15 minus 1 is 14. Yup. I know why it's not working. I looked at 9 instead of looking at 14. Why did I look at 9? Because I thought it was 10 data points. Sorry. Okay. So degrees of freedom, by the way, guys, is not 9. It's 14. My bad. Sorry. 15 minus 1 is 14. Okay. I actually looked at 9 for some reason, assuming that degrees there are 10 data points. 10 minus 1, 9. I should have looked at 14. If I looked at 14, it should be giving you 23.685. So sorry about that. 23.685. 23.685. So this should be. So let me just erase it for you. 23.685. Can you try this value, please, and let me know?
Yeah, it worked.
Okay. All right. Next question, please.
Could we go over 14 and 16? Of
14.
the same assignment.
Okay. All right. Okay, 14 and 16. Okay, 14 and 16. There's a request for 15 as well. So 14, 15, 16, all of them. Mr. Zach, the founder of Facebook, recently announced that an average person spends 60 minutes per day on the video. Assume that the time spent on the social networks is normally distributed with standard deviation 30 minutes, okay? Find the probability that 25 randomly selected persons spend between 54 and 66 minutes per day on the social media. This is a sampling distribution and central limit theorem problem. So remember, you are not dealing with one single person. You're dealing with 25 different people, okay? You're dealing with the average of 25 people. So what do you need to do? Make sure you have the formula sheet in front of you and make sure that you use the right conclusions and right formulas. So central limit theorem, CLT, okay, what are the two conclusions of CLT? Mu sub x bar is equal to mu. That means mean of the sampling distribution is the same as the mean of the population. And that's conclusion number one. And the conclusion number two is sigma sub x bar. That means standard deviation of the sampling distribution is the same as the standard deviation of the population divided by the square root of the sample size. So these are the two things that we are going to be using. So what they want you to find is this: find the probability that's average of 25 people falls between this. So probability that 54 is less than equal to x bar is less than equal to 66. By the way, probability of a single point is 0. So this, by the way, is the same as saying probability of 54 is less than x bar is less than 66. So keep that in mind. So now we have to convert it into Z. So your sampling distribution is this, which is a mean of 60, okay? And standard deviation sigma sub x bar is equal to sigma over square root of n. Sigma population standard deviation, what is it? 30 minutes. So it's going to be 30 divided by square root of the sample size, 25 people. So 25, which is 30 over 5, which is what? 6. So sigma sub x bar is 6. So this is the standard normal distribution with a mean of 0, standard deviation of 1. You use z sub x bar to go from here to there. Z sub x bar is equal to x bar minus mu sub x bar divided by sigma sub x bar. We have all the things. So we need to convert 54 and 66. So for 54, what value does it go to? You'll see -1. For 66, what value does it go to? You'll see it goes to +1. But let me show you how. So z sub x bar is equal to x bar is the mean, which is what is my x bar? X bar, mu sub x bar is 60 per day. Oh, so x bar is the point of interest, which is 54. That's what we are trying to convert. So 54 minus mu sub x bar is 60 divided by sigma sub x bar, which is 6. So z sub x bar is going to be -6 over 6, which is -1. Okay, so this maps to this. Similarly, we do the other one. Z sub x bar is equal to 66 minus 60 divided by 6, which is 6 over 6, which is 1. So this guy maps to this. Finding the probability, so now I'm going to take the background off. Finding the probability that x bar falls between 54 and 66 is finding this area. Which is equivalent to finding this area. Okay, so that's probability of -1 is less than z sub x bar is less than +1. -1 is less than z sub x bar is less than 1. Now this is the same as probability of z sub x bar is less than 1 minus the probability of z sub x bar less than -1. Now, these two values, you can find it from the table. If you look at the z-scores table, which is gonna be for 1,
It's going to be 0.684, right?
yeah, 0.68. Yeah, that's exactly what it is. For z is equal to 1, I don't want to give out the entire answer.
No, yeah, it's just because like I had that. I had the 1 and the -1. I just didn't know why it wasn't taking my answer. But then I realized it's just one standard deviation on each side. So it's just 0.684 because it's the whole little middle.
Yeah. And if you actually look up the values, it is 0.8413 minus 0.1587. And if you subtract it, it's 0.68 something. Okay, 6824, I think. So, no, it's 6826, I think, not 2426, something like that. Just do the subtraction. You guys can do it. So that's number, what number was it? 14. Any question, anybody, before I move on to the next problem? Okay, then there's a request for number 15 too. Oh, that one, Bayes theorem. All right. A garment manufacturer in Bangladesh has 3 plants named A, B, and C. Plant A produces 40%, B produces 30%, C produces 30%. Plant A, B, C has 5%, 4%, and 3% defect rates for their production. A quality control manager has just found a defective garment, and he wants to find out which plant is more likely to have produced the defective item. Answer the following question based on these things. So this is a Bayes theorem problem, very important. Now, remember, there are 3 plants. Think of it in a simple term. Let's say you are the owner of a garment factory, and you have 3 different plants that make clothing for you. Plant A, plant B, and plant C. Okay, the first plant makes 40% of the totals, the other 2 makes 30% each. Okay, and the first plant has a defect rate of 5%, the second one 4%, the third one 3%. Now, suddenly you randomly select a piece of clothing and find out that it's defective. Then now you need to figure out, based on the information given, which plant is more likely to have produced it, or the probability of which plant making this thing highest. Okay, the probability is highest for which plant? Is it plant A or plant B or plant C? So that's what you want to find out. And I define some events. A is the event that A produces the item, similarly B and C, and D is the event that product is defective. So let's see. The first one is probability of defective given that A has made it, which is easy. A has defect rate 0.05. Probability of defective given that B has made it, which is 0.04. Probability of defective given that C has made it, which is 0.03. Easy. These are just basic information given to you, is given in the problem for 5%, 4%, and 3% respectively for A, B, and C. Now comes the interesting part. Okay, where are you? A, B, and C. Find the probability of A intersection D. So find the probability of A intersection D. Now this probability could be written in a couple of ways. So make sure that you do follow the proper order, otherwise you won't be able to find it. So we could do probability of A times the probability of defective given A. That's one, right? Oh, one route. Or equivalent definition is probability of defective times the probability of A making it given it's defective. If you use this formula, these are equivalent formulas, by the way. If you use this guy, you'll get stuck. You don't know what is probability of defective. If you randomly select an item, you don't know what the probability of defective, or you don't know given it's defective that A has made it. You don't know. So you don't know this, you don't know this. So you can't use this. However, this one, you know both. So I'm going to take this guy and put it right here. What is the probability that plant A makes an item, which is 40% chance, because 40% of the product is made by plant A. What is the probability that the product will be defective given that plant A has made it, which is 0.05. That's why I kind of walk you through these things first. So this is going to be 0.4 times 0.045. So it's going to be 0.02. Okay, because 5 times 4 is 20. So that's your this guy. Now the next one is product is defective. This is the product is defective and A has made it, what we just found. Now what is the probability that a product you find is defective? Now if a product is defective, okay, probability of defective product. So now if a product is defective, what could happen? Either A could have made it, or B could have made it, or C could have made it. Nobody else could make it because there are only 3 plants. So if we think logically, we find that A could have made it, or B could have made it, or C could have made it. So we could have probability of A made it and defective plus probability of B made it and defective plus probability of C made it and defective. Now probability of A made it and defective is 0.02. 0.02. In exactly the same way, you could do the calculation for B and C. Okay, I don't know, I'm debating whether I should do it because it's the same thing. Well, since you have a final exam, I might as well do it. Probability of B and D is going to be probability of B times the probability of defective given B, which is probability of B is 0.3 times 0.04, okay, which is this number. Similarly, probability of C and D is equal to probability of C times the probability of defective given C, which is probability that C makes it, which is 0.3 times 0.03, which is this. Now you have this number, and this number, and you add these numbers. That's going to give you the probability of defective. And if I recall correctly, I think it's 0.0 something. Anybody has the number? You can just add this up. So it's going to be 0.012 plus 0.09. That's what it is. Oh, did I make a mistake? So 0.009, not 0.09, 0.009. Okay. So if you add these 3 numbers, you get 0.02 plus 0.012 plus 0.009. That gives you probability of defective as 0.041. So that should be your answer to this. Now, the next problem, next part of this problem is this: probability of A making it. So this is where the Bayes theorem comes into play. Probability that plant A has made it, given that the product is defective. So probability of A making it, given that the product is defective. So which is going to be probability of D given A times the probability of A, I think, if I recall the formula, it's easy to forget, divided by probability of defective. Okay. So probability of D given A, so you switch it, this one, times the probability of A divided by the probability of the defectiveness. So probability of D given A, probability of D given A, which is 0.04, right? 0.5, which is this, times the probability that A makes it is 0.4. All of it divided by 0.0 defective, probability of defective, which is this 0.041. And if I do the math, what do I get? Let's see. 0.05 times 0.4 divided by 0.041. That gives me probability of A given D is 0.4878. That's what it is. Can somebody check this answer to make sure that we got the right answer?
Yes.
Yes, Jonathan. Okay, good. So that's what it is. Now you should be able to do this exact same calculation for these guys. Probability of B given D, right? Probability of B given D, which is going to be probability of D given B times the probability of B, right? All of it divided by probability of D, which, let me take the background. Probability of D is 0.041 and probability of D given B is 0.04 times 0.30. And then probability of C given is defective is probability of D given C times probability of C, all of it divided by probability of D, which is going to be 0.041, 0.03 times 0.3. And this is going to give you the answer to okay, this is going to give you the answer to this, and this is going to give you the answer to this, and that's all. Okay, and based on this, which candidate? So like, as you can see, you don't even technically have to do the calculation. Probability that the plant A has produced it is almost 49%, right? So the other two plants are going to divide the remaining 51%. So it's probably plant A that did that produced the defective item. Because for this one, so let's say for this one, what do you get? 0.04 times 0.3 divided by 0.041. So 29% for this one, roughly 0.2926. And for this guy, 0.03 times 0.3 divided by 0.041, which is 21%. For this guy, 0.2195. So if you look at the probabilities, we can see for A, the probability is the highest. For B, second highest. C, the third highest. So if you strictly go by the mathematical calculations that we did, the probability that the plant A has made this defective product is the highest, which is almost 49%. So we'll blame it on A, plant A. Who asked for this? Is this Jonathan who asked for it?
Yes.
So this is a good problem, and you will be seeing a problem on Bayes' theorem on the final exam. So make sure that you know how to solve problems like this. Okay, good. Next, there is a request for number 16, I think. This is 15, number 16. It's exactly the same problem, okay? But I'd still do it. I want to help you guys out. This problem, I always make mistake. So let me make sure that I don't make the mistake. In the general population, 1% of the women between 40 and 50 suffer from cancer, okay? You either have cancer C or you do not have cancer C prime, okay? So probability that you will have cancer is 0.01, 1%. Probability that you don't have cancer is 0.99. You either test positive or you test what? Negative. Okay. So a hospital testing for breast cancer, so that means they're testing for C. Okay. 90% of the times they are accurate, so that means that's 0.9. Okay. Now they're inaccurate 10% of the time, so that's going to be 0.1. Now, when you create this table, make sure that you understand what you're doing, because even after doing it many times, I still kind of make mistakes. So you're just learning it for the first time, and it's very likely that you'll make mistake. So when you're testing for a cancer, 90% of the times their results are correct. That means person has cancer and the result is positive. So that's good. That means 10% of the times they get negative results when the person actually has cancer. So those are the bad ones. So it will be in this column, okay? And 85% accurate when testing negative. So that means that will be the next column. 85% of the times they test negative when the person does not have cancer. So good. But that means 15% of the times, meaning 100 minus 85, 15. 15% of the times they say, oh, did I make a mistake? I think I already made a mistake. Hold on. Sorry, you see? Okay, make sure that I don't get it wrong. 85% of the times they test negative, okay? So when the person does not have cancer, 85% of the times they are accurate, meaning testing negative. So I should be in this one. So 0.85. And 15% of the times they test positive. So that means this row, okay? If they test positive, but the people don't have cancer, that's bad. So that's 15%. All right. So that's how you create the table. Now, find the probability that a woman tests positive given that she has cancer. So we are looking for probability of testing positive given that the person has cancer, which is easy. Given, what is given? The person has cancer. So this is the first column we are looking at. So that means that's just 0.9. So the next, finding the probability of positive. So that's the interesting part, probability of testing positive. This one is probability of testing positive given that the person has cancer. Now, can I ask you guys a question, even though it's not part of this problem set? Can you tell me probability of testing positive given that the person does not have cancer? What is that value? Can anybody take a shot at it?
0.15.
Exactly, 0.15. Who was it?
Jerry.
Jerry, thank you. Because we are looking at this column, right? C prime, and we are looking for testing positive. So let me ask something else. Probability of testing negative given that someone does not have cancer. What is that gonna be? Somebody other than Jerry. Probability of testing negative given that the person does not have cancer, meaning C prime means does not have cancer. What is that value? Can somebody help me out? Alicia?
0.85.
Yes, you got it. All right, I'm surprised. I was a bit getting worried. How come Alicia is not talking today? Okay, thank you, Alicia. All right, so you get the idea. So now the probability of testing positive, okay? How can you test positive? Two ways. You can test positive when you don't have cancer, and you can test positive when you do have cancer. So you test positive and you have cancer, plus you test positive and you don't have cancer. These are the only two possibilities. It cannot happen in any other ways, okay? It cannot happen in any other ways. So probability of positive. So probability of testing positive and cancer. So let's say probability of, so this one, I'm not gonna show you the two different ways. So you're gonna test, write it down like this: probability of cancer times probability of testing positive given that someone has cancer, plus probability of not having cancer times the probability of testing positive given that someone doesn't have cancer. Why did I put this little one here? I don't know. All I'm looking for. This is just testing positive. So now probability of testing positive is going to be probability of cancer is 0.01 times the probability of testing positive given that someone has cancer, which is probability of testing positive given that someone has cancer, okay? Given that someone has cancer and testing positive is going to be 0.9 plus probability of not having cancer, which is this 0.99 times probability of testing positive, probability of testing positive when you do not have cancer, which is 0.15. If I do these calculations, that gives me probability of testing positive, which is 0.09. So, oops, not 0.09, 0.9 times 0.01 plus 0.99 times 0.15. That's going to be 0.1575. 0.1575. That is the probability of testing positive. Now you found answer to this problem, this guy. In the next one, what do I ask? Probability of cancer given positive. So that's why you use the Bayes theorem. Probability of cancer, probability of testing positive. Sorry, I take it back. Probability of having cancer given that someone tests positive. Probability of having cancer given that someone has tested positive. So this is going to be probability of testing positive given that someone has cancer times the probability of cancer. All of it divided by the probability of testing positive. And I'm going to go ahead and do it. Probability of testing positive 0.1575. Probability of cancer is 0.01 times probability of testing positive. What is it? Testing positive given that someone has cancer is 0.9. And if you do the math, you should get 0.01 times 0.9 divided by 0.1575. That gives you 0.05714, or about 5 or 6% chance. Okay, that's what it is. Now, the interesting part is this. Interesting part is the next one. What if someone tests positive twice? So probability of having cancer given that someone tests positive twice. Now that's where you kind of have to redraw the diagram. So you test positive, you test negative. Now, what is the probability of having cancer versus not having cancer? So I need your help here. So when you're testing second time, what happens? You cannot test a person second time unless you already have tested the person what? One time before, right? That cannot happen logically. You cannot test a person second time when you or what I'm trying to say is you cannot test a person second time unless you tested the person first time. So what are the values of C and C prime gonna be, everybody? I want your feedback on it. So this is where some people might go wrong. So please help me out. What is C in this case? And what is C prime in this case? In the last case, just to remind you, in the last case, C was 0.01 or 1%, C prime was 0.99 or 99%. What is it in this case? I'm using red so that you can see it and pay special attention to it. Anybody?
Would C be 0.10?
0.10, okay. Did I say 0.10 in the problem? Well, yeah, I did actually. Yeah, 0.10, I guess. 0.10, and this should be 0.9. Now, I kind of made up the problem here. I changed it. In reality, it should not be 0.10. Based off of your calculation, it should be what? Because if somebody tested positive once, the chances that the person has cancer is 5% or 0.05, right? So this technically should be 0.05 and this technically should be 0.95. But people are gonna make mistakes. That's why I kind of gave you a specific easy number, 10%. So you do the exact same calculation. Don't use this because this is what ideally it should be, because this is what you get from the last part of the problem. For some reason, the reason I gave you 10%, because some people will get this answer wrong, then they're going to propagate the mistake for the other problems too. So to avoid that scenario, I just gave you 10%. Because if you don't get this part right, then of course the next part is going to be wrong because of this number. So I kind of wanted to avoid that situation and give you guys a little break. And that's why I said, oh, okay, it's 10%. If I were to say 5%, some people would guess, hey, the answer to the last one is 5%, put it 5%. So I tried to be a little bit creative, but I don't think I was very creative. People try to guess things. So yeah, and this is 0.9, it doesn't change. This is 0.1, this is 0.15, and this is 0.85. And that's it. Then you do the same calculation again. Okay, so that does this problem. What number was it? Was it 16? Yeah, 16. So there was request for 14, 15, and 16. I did all of them.
Professor, could we do problem 21, please?
Okay, Alicia, 21. Oh, the curates problem. A drug named curates is 60% effective in extending the life of an AIDS patient by 20 years or more. Find the probability that more than 3 patients or less than equal to 5 patients extend lives. This is a binomial distribution. Why? You have a fixed number of trials, okay, 5 people. So n is equal to 5. There are 2 outcomes, either extend life or not extend. Extend or not extend, okay? Then probability is fixed, which is 0.6, okay? And the trials are independent because what happens to one patient does not influence what happens to other patients, okay? So let's go ahead and do this. Your formula is probability of x is n c x p to the power x times 1 minus p to the power n minus x. We want to find out the following. Probability, is it what I am looking for? Find the probability that more than 3 patients or less than or equal to 5. So more than 3 patients, meaning 3 is less than x or less than equal to 5. And this is a discrete probability distribution, okay? Discrete probability distribution. So it's gonna be probability of x is equal to 4 because it cannot be equal to 3 plus probability of x is equal to 5. So you just need to find this probability and this probability using this formula and then add the results. So I'm just going to do one of them for you. Okay, do this and then I will let you do this one and then you can add it. So I'm going to find probability of x is equal to 4, let's say. So it's going to be n is 5, right? X is 4 in the first case. So it's going to be 5C4 times P is 0.6. P is 0.6. So 0.6 to the power X. X is 4 times 1 minus 0.6 to the power 5 minus 4 because n minus x. Now, how do you calculate 5C4, which is 5 factorial divided by 5 minus 4 factorial times 4 factorial, which is 5 factorial divided by 5 minus 4 is 1. 1 factorial is just 1, right? So 4 factorial, that I could write 5 times 4 factorial divided by 4 factorial. These two cancel out, that gives you 5. So this is going to be 5, this number, times 0.6 to the power 4 times 1 minus 0.6 is 0.4 to the power 5 minus 4 is 1. 0.4 to the power 1 is just 0.4. And then you'll be doing the exact same calculation for x is equal to 5, which is going to be 5C5 0.6 to the power 5 times 1 minus 0.6 to the power 5 minus 5, okay? And then it's going to 5C5 is just, you can do the calculation, that's going to be just 1 times 0.6 to the power 5 times 0.1 minus 0.6 is 0.4 to the power 0. Hold on 1 second, guys. Just 1 second. Okay, so that's going to be this, and 0.4 to the power 0 is 1. Remember that. Okay, then you do the calculation, you add these two numbers, and that's your answer. Alicia, is it okay?
Yes.
Okay, good. Any other questions, anybody? No questions? That's all? Okay, good. If there is no other questions, that's all for today. So what I will do, if I can, I might, my objective is to help you guys out as much as I can, okay? So if possible, I'll try to hold another office hour right before the final exam, which is Monday, so Sunday night. Okay, so go over this review that I did. That should give you hint on many problems, or not hint, actually, I solved the problems. You'll be able to solve many of the problems. And maybe I'll try to help you once more last time before the final exam on Monday, which might be on Sunday night. I might have another office hours to help you out. Okay, I'll send an email if I do hold one. Please also let me know how you are feeling. Do you need additional help or not? If you do need it, I'll definitely be happy to hold another office hour before the final to help you out. Okay, I want you to do well on the final. I want you to be successful and do well in the class, and move on with your life and enjoy. Okay, so work hard last few days, and it'll be over, and the summer is around the corner, so you'll enjoy. So let me know if you have any questions. You can send me email from the system, okay? Or you can even text me. Just email me, all right? Then I can respond to your questions and answer your questions that you may have. All right, that's all for today. Thank you so very much, guys. You have a wonderful day and rest of the week and weekend. Thank you and take care.
Thank you.
Thank you.